This data visualization video tries to provide some guidance on when you might want to choose a table or a graph as the most effective technique for the data that you're trying to portray. Now, most people don't think of a table as a data visualization technique, but on the contrary, it is probably the most popular technique or tool used for data visualization. But to understand that better, let's try to understand essentially what a table actually is. A table is a structure that uses text, which might be words or numbers, to organize data in columns and rows. So in a table, the key requirement is that all the data in the columns, so these are the columns X and Y, must be related to each other in some way. All of these data have something related to X, and all of this data in Y have something related to Y. And all the data in the rows must be related to each other. So all the data in row L have some relation to L, all data in row M have some relation to M, and all data in row N have some relation to N. That is the key requirement of a table. Now that sounds intuitive, but unfortunately, there are a lot of invalid tables that you'll see and that sometimes we create. And the first kind of invalid table that's quite common is that the rows and columns do not have any particular correspondence. So in this example, you have the rows and columns, the same as in the first table, but the data elements A, B, C, D, E, F do not have any obvious correspondence to the rows or to the columns in which they're placed. Now, this is an extreme example where they're just sorted kind of alphabetically. Sometimes it's one element doesn't quite have the correspondence. But if there's not that strict correspondence between rows and columns, then this is not a valid table. Now, another very common but invalid form of table is where you have only one row or only one column. So in this instance, the rows and columns do correspond appropriately, but there's only one column. Well, this is just a list, and you can use a bulleted list to represent this information. If you don't have at least two rows or at least two columns, then there's no point using a table to represent that. So that's not a valid table structure either. In contrast, a graph is a different type of visualization. And here is a quotation from Stephen Few, one of the world's leading experts on data visualization. A graph is a visual display of quantitative information. So the key here is that a graph displays quantitative, that is numeric, countable information. It can, and normally also does include text, but essentially there must be some numbers there to justify a graph being used. In a graph, the values are displayed with an area delineated by one or more axes. So in almost all of these graphs, there's an x-axis where the x is the horizontal axis, and there's a y-axis, which is the vertical axis. But that's not the case in all. Another common type of axis in graphs is a radial axis, also referred to as polar axis or used for polar coordinates. And you have that is famous in a pie chart and some other kinds of charts where the axis goes around 360 degrees in a circle. So that's another kind of axis. But there must be one or more axes to portray and lay out the data that's represented in a graph. Another key point is that values in the graph are encoded as visual objects positioned in relation to the axes. So if you have an x or y axis, each of the values are encoded with some sort of picture, some sort of object in relation to the x or y axis, or the radial axis in some relation to the circular arrangement of the graph. Then a third key aspect of a graph is that axes provide scales, which might be quantitative and categorical, that are used to label and assign values to the visual objects. So there's some sort of scale that indicates what each point along the axis or which level or point along the axis means, and the axes with the visual object within them are what constitute a graph. So the next question then, now that we understand what tables and graphs are, is when we should use a table versus when we should use a graph. So when should we use a table? Here's again another quotation from Stephen Few. So if one or more of these are true, then probably a table would be preferred over a graph. And this again is from Stephen Few. First, in a table, you're very much concerned with specific values. So the specific exact numeric values are important. You're not just looking for the big picture. The tables list the specific values in every instance, and so that is one major advantage they have over graphs. Then in a table, you want to compare individual values, but not entire series of values to one another. So for instance, here you'd like to compare July 1993 sales, specifically with August 1993 sales, and you're not necessarily looking at all 1993 sales, but you're looking at one point to one point comparison at a time. That is something that is very easy to do on tables, but if you don't necessarily want to compare the big picture, then tables are good for that. Another key point is that precise values are required because graphs usually show a relative position, but it's very hard to know the exact numeric value, but that's what tables give. They give precise values for any point when that's what you want to know or what's the people you're creating the visualization for want to know. Then also the quantitative information to be communicated involves more than one unit of measure. So we don't have that example here, but if, for instance, you want to show sales here in euros, and you also want to show the percentage of sales at the same time, and maybe you want to convert to a foreign currency, such as dollars, for instance, you want to show that all of them together, tables, you can show as much information as makes sense. It gets pretty cluttered when trying to present that in a graph. And the final point is that you want to include both the summary and the detailed values. So in this example, you have the monthly sales for each sales for various years, and you also have the summary here, the total annual average sales, and you're showing both individuals and the summaries. In that kind of situation, tables are usually more effective than graphs. So some basic principles of good designs for tables. So there's a lot of principles, and I'll just go quickly over a few. First, think about the sort order. Don't just use a random or default sort order. Carefully think about the sort order that makes the most sense in a particular case. In this table, the rows are sorted by year. That makes intuitive sense. And the columns are sorted by time order. They're not sorted alphabetically. There's a logical order of what people would expect. And so think carefully about that. The default is usually alphabetical sorting, and that's really only useful if the user, the reader, knows in advance what they're looking for. So like if you have several employee names, like maybe 100 employee names, and you sort them alphabetically, if the reader knows the employee they're looking for, then it's easier to find. But if it's many company names that the reader doesn't necessarily know, alphabetical sort is just as good as random. So only use alphabetical sort as a last resort, or if you really know users want to look up something they know in advance. Grouping data, such as summaries or hierarchies, can be very helpful to the understanding. If there's hierarchical order or in groups, like here's a kind of grouping, there's an annual grouping, but if you have maybe quarterly grouping, if that's something that's useful, you could have quarterly columns in this table, depending on what your reader might use. The alignment of cells in general, there are some conventions that are usually more readable. One is that text in general should be left aligned. We don't have any text in this example, but generally any textual data in the cells should be left aligned, and any numbers should be right aligned. Now note that this text, these are headers, and they are right aligned because the numbers that they represent are right aligned. That's normally what you would want to follow. And a very important point is that when you right align numbers, make sure that if there are decimal points, the decimal points line up. If there's different decimal points for each number, the decimal points must line up. That is critical. In general, I mean, really, you should greatly avoid centering the data cells. That's it, cells of the data. It always almost looks bad. It's hard to look up data. The only exception is that you might center the header row. That could be acceptable, but centering the data almost never works. It's either left align text or right align the numbers. You should highlight the header rows in the rows and columns. In this particular case, they're not highlighted with bold, but there's a simple line in each case that demarcates the headers from the contents, and that works. Make it very clear what are the headers, and that they're different from the actual data in the main table. Another technique which is very much underused is that you should highlight any data of special interest. And you can see that in this example, the audience for this table is mostly interested in July 1996 sales. And so the creator highlighted not only July 1996, but all July data for all the years leading up to 1996, and also all the 1996 monthly data leading up to July 1996. And this makes it much easier for readers to compare these numbers, and it also draws their attention to them. You can use boxes like this, or you can use bold, you can use color, you can use an arrow. But the point is, think about what your reader would like to know. Think about the story you want to tell, and use highlights to draw attention to that. There's a number of other principles, and here's some slides that have links. The Ultimate Guide to Designing Data Tables, and another one, Web Typography, Designing Tables to be Read, Not Looked At. Then next, on the converse, when should we use a graph instead of a table? Now that we see that tables are very useful, but when is a graph better? In general, whenever we want to portray patterns, trends, and impressions. So in contrast to tables, in a graph, you don't usually have precise numbers. And the point is that the precise numbers are not important for the story. So for instance here, this compares domestic sales with international sales. And it's hard to know the exact sales for any month because the graph doesn't pinpoint that. But what strikes you here first are that domestic sales are much higher. They start at 4 times higher than international sales, and they rise up to around 7 times higher. And domestic sales have an upward trend. There's some dips, but the general trend is upward. In contrast, the trend of the international sales is pretty flat. It's a dip in August, but it comes back, is flat over time. If you were to look at that with all that data in the tables, you would not easily see these trends. But with a graph, it jumps out at you. Conversely here, the specific numbers are not important. It's a trend that matters. And that's where graphs excel over tables. So some specific or general points, as Visual Matter says, a picture is worth 1,000 words, but a good viz or a good data visualization is worth millions of words. A graph can compress pages of information into a simple image. It lets the audience quickly process information. They can see the trend right away rather than trying to wade through a bunch of numbers. A good visualization grabs attention. It helps people to remember the story you're trying to tell, and it really looks professional. So with these guidelines, hopefully you're better positioned to appreciate that some stories are better told with tables and to appreciate which stories are better told with graphs. And you have an idea which to choose depending on what story you're trying to tell.